Hello and welcome to the Chandar Academy. In today's video we are going to solve the second part of this exercise about a study of function. In the first part we solved the first, second and third equation, and in this part we will try to solve the fourth and the fifth equation. In the first part we proved that the domain of definition of the function f, which is a rational function with which the denominator cancel for x is equal to 2. Okay, so this thing is equal to 0 in x is equal to 2. That means that the domain is equal to all the real numbers except 2. Then we proved that for all x in the domain of definition, f of x can also be written as minus x plus minus 3 over 2 minus x. And then we found the limit of f just before the forbidden value 2 into minus, just after the forbidden value 2 but in 2 plus, so coming from the right side, and then in minus and plus infinity. In this part we will first try to find the slant, the vertical, and then the slant asymptote to CF, which is the curve of f. So what is a vertical asymptote? A vertical asymptote is a line that is never reached but approached by f. And in this case, we see that in 2, we are going to minus the infinity. So in 2, we are going to minus the infinity on the left side. So on the left side, the curve will do something like that, and on the right side it goes to plus the infinity, so which is something, say, like that. And here we have the straight line of equation x is equal to 2, so the vertical line that goes through 2, that is never reached but approached by the function. And this is what we call a vertical asymptote. And so we can conclude by saying that the vertical asymptote to CF is the line of equation x is equal to 2. And we have solved the first part of the question. Second part of the question, we will wonder about the existence of a slant asymptote. Okay, a slant asymptote will be the same thing, but except that it will be something that is approached in plus and minus the infinity, and that will have the equation of a straight line. So an equation y is equal to ax plus b. In real life, that means that our function f of x minus y with this equation, if we find the right coefficient here, will tend to 0 in plus or minus the infinity, because in plus and minus the infinity we will approach this line without never reaching it. Okay, so maybe something like that. We approach the line without ever reaching it. Okay, so this thing and this thing goes to 0. This is what we are talking about here. And here we've got some luck, and this is the way your exercise is constructed, because we have here f of x, which has the equation of something that is a straight line, plus something that will obviously go to 0 in plus and minus the infinity. And so we can deduce. So let's call y is equal to minus x the supposed, okay, we suppose the supposed slant asymptote to c of f in plus and minus infinity. Let's prove it. How do we prove it? We've got f of x minus y of x, which is equal to minus x minus 3 over 2 minus x. Okay, so let's say plus minus 3 over 2 minus x minus x, which is the equation of y. And this thing, so minus times minus is equal to plus. And we've got minus x plus x, and we've got this thing is equal to minus 3 over 2 minus x. And obviously, this goes to 0 in x tends to plus or minus the infinity. Why? Because this thing goes to plus the infinity in when x tends to minus the infinity, and this thing goes to minus the infinity in x tends to plus the infinity. And a constant divided by plus or minus the infinity is equal to 0. Okay? And so with that, we just prove that y of x is an asymptote to c of f in plus or minus the infinity. And so we say it, y that given x gives back minus x is the slant asymptote to f, to c of f in plus minus infinity. And we have solved our question. Now we will want to study the variation of f. So variation of f. Let's remind that for all x in df, the domain of definition of f, we've got f of x, which is equal, we will use the second value, minus x plus minus 3 over 2 minus x. And we see that for all x, when this thing is different from 0, okay, so for all x in df, we can derivate f of x. And so for all x in df, we can derivate f, such as f prime of x, which is the derivative, is equal to, we first derivate this one, minus x, plus minus 3, we keep the coefficient, times a first minus, so here we've got something like 1 over u prime, over u, sorry, prime, and this is equal to minus u prime over u squared. And so here we've got the first minus here, we've got u squared 2 minus x squared here, and what is u prime, the derivative of what down the division sign is minus 1 times minus 1, and here we can cancel 2 of the minus signs, and we are left with, oh sorry, here it's a minus 1 is equal to minus 1 plus minus 1 minus 3 over 2 minus x squared. And to study the sign of this, we'll want first to find okay, we can conclude right now. Here we've got something that is strictly negative, because minus 1 is strictly negative, and something that is here plus minus this thing strictly negative. Why? Because 2 minus x squared is a square, so it is strictly positive, which implies that 3 over 2 minus x squared is strictly positive, because 3 is strictly positive, of course. And when we add a minus, we've got the opposite thing, okay, because we multiply the inequation by minus. And so this whole thing here is, of course, strictly negative. And when we add two things strictly negative, we got something that is strictly negative all times. And which means that we will go from minus the infinity, from plus the infinity, which was the limit, to minus the infinity, and on the other side to plus the infinity, from plus the infinity to minus the infinity. And this is the way to go. So now that we have the two indication, we can do a little variation table. We've got x, f prime of x, and f of x. Okay, so what are the important values? Of course, minus the infinity, 2, which is the forbidden value, and plus the infinity. For all values of x, so we've got f and f prime that is not defined on 2, but we will have something negative as f prime of x, negative, negative, and so we will go down each time, and we will go down from plus the infinity to minus the infinity, and as well from plus the infinity to minus the infinity. We've proved that in question 3. And as we know all these things, we can now graph f of x. So we want to graph f of x, so let's do a big graph. So here I have x, here y. What do I know? I know the slant asymptote. I know the vertical asymptote first. In 2, I know the slant, I know the vertical asymptote is this line, this vertical line of equation y is equal to x is equal to 2. Now I know a second asymptote, which is the slant asymptote. So here, if I do a 1 here and a 1 minus 1 here, my slant asymptote will be the straight line of equation y is equal to minus x. Okay, and we will have the function that will go near this slant asymptote in plus or minus the infinity. Also, I know that in minus the infinity, I will be close to the asymptote. So here, and that's in 2 minus. So on this side of 2, I will go to minus the infinity. So here, same thing here. In 2 plus, I go from plus the infinity, and in plus the infinity, I go in minus the infinity. And now I can graph the function. So I go from here to 0, and then I go evenly to minus the infinity. Same thing here. I go from plus the infinity. I go from plus the infinity, and then I will approach the slant asymptote. And here we have the curve of f with the forbidden value in 2. And now I have solved the whole exercise. Hope you enjoyed the video. See you soon. Bye.